Hello everyone, I hope you all are doing well. So today we will be doing a short presentation on the assignment problem of quantitative techniques. I'm Sogat Pastula and I'll be walking you through the assignment problem. So first, let us understand a little bit about assignment problem. So it is a special class of linear programming that involves in determining the most efficient assignment that a people can do. For example, there might be five different projects and five different people with different efficiency. So our job will be to assign the right person to the right project. So it is often used to minimize the total cost or total time of performing a task. And one important characteristics that we must keep in mind is that only one job or only one worker is assigned to a mission or a project. So here we cannot split the tasks between two workers for more efficiency. Moving on, each assignment problem has a matrix associated with it, and the matrix consists cost associated with a certain assignment, project, or a distance. And the most efficient algorithm to determine this assignment problem is the Hungarian method, also known as the floods technique. So in this, what we do is we actually see the picture as a whole and then assign individual tasks to individual person or a project. And since it was developed by Harold Kuhn, and he gave the name Hungarian method because it was developed by two different Hungarian mathematics. Furthermore, we must also understand that it is only possible to use the assignment problem in use the Hungarian problem in even matrices, such as 4 into 3 matrix will not do the trick. We need either a 4 into 4 or a 3 into 3 matrix. In case there is a 4 into 3 matrix, then a separate set of column must be added with all zeros known as a dummy row, a dummy column. Furthermore, let us explain this assignment problem with a short example. Let us imagine that a company has only five jobs and there are only five workers available to do the job. And the number of hours that each worker required to complete a specific task is given in the matrix below. So the first thing that we do is we find the minimum element in each row. Mind it, we find the minimum element in each row and subtract it from all the elements of that particular row. So here in the first row, the W1 row, the minimum element is 24. So we subtract 24 from all other elements in that particular row. So in another case, the minimum element is 23, 18, 24, and 28, and so on. In step 2, now what we do is we find the minimum element in each column and subtract it from all the elements of that particular column. So as we can see, the minimum element in this column is 0, so we subtract 0 from all this element. And furthermore, in this column, the minimum element is 1, so we subtract 1 from all the previous elements, and this is the result. Such that. So now in step 3, what we must understand is that after subtracting minimum element from each row and minimum element from each column, that will create at least one zero in each row and column. So after what we do is that the zeros are what we are going to assign. So starting from the first row where there is 0, we actually assign it. So starting from row 1. So this is the 0 that we definitely assign it, and then we cancel all the zeros in between since this tax has already been assigned. Then we cross out this column as this tax has already been assigned. We cross out this column with a straight line. Again, so we do it from first row, then move on to second row, right? We assign this tax, and since there are no other zeros, we simply cross it with a straight line. Then move on to third row, we assign this zero, cross it. Moving on to fourth row, we assign this zero, and then we cross it. So that's how this is done. Furthermore, now if an optimal assignment is not formed, we go to step 4. So if we have five straight lines, then we do not need to go step 4 because we already have our answers, because each task will be assigned to each individual workers. But since we do not have five straight lines, we go to step 4. So in step 4, what we do is ensure all zeros are covered with minimum 1 line, and we find the minimum element not covered by any line. So In this, what we have ensured is that every zero is covered with at least one line. As we can see, there is either a vertical or a horizontal line covering each zeros. Then what we again do is that we find out the minimum from the elements that are not cancelled by the straight line. So here, these are the elements in question, and the 5 is the minimum element. So subtract the element from the elements not covered by the line. So the minimum element in our case is 5. And also add the same elements to elements which are at the intersections. So what we do is we subtract it from the minimums, right? And we add to the intersections. So if we go back, so these are our intersections. See, as you can see, here is our vertical line crossed by a horizontal line. So in this intersections, we add that minimum number. And furthermore, we get another matrix and we repeat to step 3 where we cover all the zeros with straight line again. And since 5 straight lines are needed, and as we can see there is 1, 2, 3, 4 and 5, so our assignment is complete. Now let us see what we have assigned to. J1 to W3, here is J1 to W3, so it requires 18. This 18 hours is from the very first matrix. Similarly, we assign job 2 to worker 2, and worker 2 will take 24 hours. Job 3 to worker 1 will take 21 hours. Job 4 to worker 4 will take 24 hours. Job 5 to worker 5, and worker 5 will take 36 hours. And as we can see, if we sum up all, we get the minimum total time of 26 hours. So this is how we solve an assignment problem. Now, here we calculate the minimum time required by the workers to complete all 5 tasks. Now, if this case was from a maximization part, where we have where a salesman needs to travel maximum distance in shortest amount of time, or a teacher need to complete most of its class schedules. So in that case, we need to do is that we need to form an opportunity loss table. So the opportunity loss table is formed by subtracting the biggest element in the problem from all other elements. So once we form this opportunity loss table, then we repeat the same steps that we have done in the assignment problems. So with this, we come to the end of our presentation, and I hope you understood a little bit about assignment problem and how Hungarian method is used, and it is the most effective method in the assignment problem. And then similar Hungarian method is also used to solve the maximization problem. Thank you and see you again.